Alright, for this video, we're going to move over to 6.2, and this is where we're going to solve a linear system, but now we're going to do it by a second method, which is called this right here, substitution. And this is one where we don't graph, it's more of an algebraic method of solving it. And we're just going to take a look at number 1, 2, and 5. Okay, if you look at the question to ask yourself right here, whenever you solve a linear system by substitution, here's the main thing. You have two equations. You ask yourself, are there any variables that are solved for or isolated, meaning it's completely by itself? And then once you ask yourself that question, then you want to do this goal. Okay? Once you have a variable by itself, you want to substitute an isolated variable's quantity into that same variable for the other equation. Okay, that probably sounds a little confusing now, but let's kind of go over what we mean by that goal. Let's look at the first one. Okay, if I look, I have two equations, y equals x plus 1 and 2x plus y equals negative 2. Now, if I ask myself the question, are there any variables solved for? Yes, there's only one variable that's by itself, and it's this y right there. That's the only one that's by itself. So since that's by itself, I'm going to follow this goal. So it says substitute an isolated variable's quantity. Well, the isolated variable's quantity for this is this x plus 1. I'm going to put little parentheses around it. And I'm going to substitute that x plus 1 into the other equation's y value. Because it's like saying, all right, if this y equals x plus 1, then I can replace this other y with this x plus 1. So I'm just going to work with the second equation. I'm going to have 2x plus this y changes to this quantity, x plus 1. And then I set it equal to negative 2. So the whole reason that you did that was that now you have an equation that you can solve for because I only have one variable. I just have x in it. It's a very simple equation to solve for. So if I solve for the 2x plus 1 equals negative 2, I can combine the x's, which gives me 3x. So I have 3x plus 1 equals negative 2. And then I just have two steps. I can subtract 1 from both sides. So I get 3x equals, let's see here, negative 2 minus 1 is negative 3. And then if I divide by 3, I'm going to get x to equal negative 1. Well, now we're not just done, because just like when we solved graphing, you have to find the point of intersection. So you have to find the x value at that point of intersection and the y. Well, to get the y value, you're going to substitute again. I'm going to take this x equals negative 1, and I'm going to plug it in to this first x. I could plug it into either x, but it's much easier to plug it in that first one because y is solved for. So when I do that, I have y equals, and then this x right here, I replace it with negative 1, and then I add 1 to it. So negative 1 plus 1, 0, so I get y to equal 0. So if I graph both of these lines, the point of intersection is going to be at negative 1, 0. Okay? All right, let's go to number 2. All right, and it has check solution. I'm not going to do that on this one. I'll probably show that in class separately. All right, if I look at number 2, I'll make this even a little bit bigger there for you. All right, I asked myself, is there a variable completely by itself? Well, the only one that's by itself is this x, because I have x equals 4y minus 1. So what I'm going to do is I'm going to take this whole quantity, 4y minus 1, and I'm going to put this in the other equation, the first equation. Now, since this x is solved for, that means I plug this into the x for the first equation. So when I do that, I'm going to have 2 times x, which is this quantity, 4y minus 1. And then I put this plus 2y equals this 3 right there. So now, after you substitute, you have an equation where you only have one variable. In this one, I just have y. So I'm going to solve for this variable. I'm going to distribute this 2. So 2 times this 4y is 8y. 2 times that negative 1 is negative 2. Bring down the plus 2y equals 3. I can combine like terms. 8y plus 2y is 10y. So we have 10y minus 2 equals 3. Okay, then I got two steps. I'm going to add 2 to each side. So I get 10y to equal 5. Then I divide both sides by 10. Now I don't get 2 for this. 5 over 10, that reduces to 1/2. So I'm halfway there. I have the y value. Now I need to get the x value. Now, when you plug the y value, you could either plug it into, let me use my laser here. You could plug it into this y or this, but it's much easier plugging it into this y because this x is by itself, and that's what we want to find. So I'm going to take this 1/2, I'm going to plug it into this y right there. So when I do that, I'm going to put an arrow here. I'm going to have x equals 4 times y, which we figured out this y is 1/2. And then it's what, -1 right there, so I'll put -1. So when I multiply, 4 times 1/2 is 2, and 2 minus 1 is 1, and that's what the x value is. So let's list our answers in ordered pair. It's 1, 1/2. So if you graph both of these lines, they would intersect at 1, 1/2. All right, let's do one more. Let's go to, I think it's, all right, we're going to go to the last page, number 5 we're going to look at. Because the other ones that I didn't show, the variables are not solved for. Let's make this bigger. All right, so for number 5, we're asking ourselves, all right, do we have a variable by itself? And the only variable that's by itself is this x. Right? This y is not by itself because there's a 2 with it, and the x and the y above are not completely by itself. So what that means is I'm going to take this whole quantity, and since this x is by itself, I'm going to plug it into this x. So 2y, I'm plugging into that x. So when I do that, this first equation changes to 2 times x, which is this 2y, and then I have what, plus 6y equals this 15. So then I only have y that's in there. So I just multiplied 2 times 2y is 4y. So we have 4y plus 6y equals 15. I add these. 4y plus 6y is 10y. We're just going to get another ugly fraction here. I divide by 10 both sides. 10 does not go into 15, but that reduces to what, 3/2? Now to get the x, I want to plug this y value. Again, I could plug it into this y or that. It's going to be much easier to do this because x is by itself. So I'm going to have x equals 2 times y. So I'm going to have x equals 2 times y, which is 3/2. So when we do that, we're going to have, I'm going to put an arrow down here, we're going to have x equals 2 times this y. We figured out y is 3/2, so it's times 3/2. And 2 times 3/2, the 2's cancel, so x just equals 3. So the answer for this, the x value is 3, the y value is 3/2, or you could say 1.5. So if you graph these two lines, that's going to be the point of intersection. And that is all.